All right, 7th graders, we're going to deal with some functions and equations. Functions are basically, one way to think of them are tables, and one way to think of them is a machine. And I'm going to talk about that here in a second. Let me get you on the right page. We're on page 371. Okay, so let's get some definitions in. Okay, a function is a pairing of each number in a given set with exactly one number in another set. So it is a pairing of two numbers. Okay, inputs. Okay, starting with a number called the input. The input is a starting number. Okay, the output is the number that it's like a machine. You put a number in, it does something to it, and it spits it out. So it's the starting number. The output is the ending number. Let's do it that way. Okay? The domain is another name for all of the input values. The range is a name for the output values. Okay, so in the book, it's got this little machine. You put a number in, the top, that's the input, and it goes inside and it does something to it inside, and then it spits it out and it becomes the output. Okay, so it might be something like inside here there's a rule that they're multiplying by 2. So if you put in a 2 and then out would come a 4, that would be a function. Okay? That's it. So evaluate the function y equals 5x when x is 7. So all you're doing is saying, hey, we're going to put in a 7 in our machine, goes in there, and when it comes out, what's 5 times 7? Y equals 35. So it's kind of a fancy way to ask you to evaluate an expression. Put the 7 in, 35. Make an input-output table for the function y equals x minus 1.3 using the domain 0, 1, 2, and 3. So a lot of times, here's our input-output table. I usually use x's and y's. Usually the x is the input and the y is the output. Okay, so here's our machine. We're going to put into our machine the domains, the inputs. There's a fancy name for the inputs. So those are going to be the x's, 0, 1, 2, and 3. So here's our equation, y equals x minus 1.3. If I put a 0 in right there, what's 0 minus 1.3? Negative 1.3. Then I put in the 1. What's 1 minus 1.3? Negative 0.3. What's 2 minus 1.3? 0.7. What's 3 minus 1.3 would be 1.7. And that's it. Those are your inputs and your outputs. It says then state the range of the function. So the function ranges from negative 1.3 up to 1.7. Okay, or actually they want you to name all of them. These right here are the ranges. In their table, they just have them going the other way. Make an input-output table for the function using the domain. Okay, so you make, right away I see x and a y. So they want me to put in negative 2, negative 1, 0, 1, and 2. So we'll put in negative 2. 2 times negative 2 plus 2. That's negative 4 plus 2 is negative 2. Then we put 1 in. 2 times negative 1 plus 2. So negative 2 plus 2 is 0. Then we put in 0. 2 times 0 plus 2 is 2. Well, now I start to see a pattern. I'm going to guess this one's going to be 4. So 2 times 1 plus 2 is 4. Then 2 times 2 plus 2 is 6. The range is right there. Negative 2, 0, 2, 4, and 6. Sorry, that's all sideways like that. There's our range. That's it. Okay, now they're giving us the table. We have to figure out the rule. What are we doing to x to get y. A lot of times I go to the easy, like 0. Look at this one. What do you do to 0 to get 2.5? Well, it looks like I'm an x plus 2.5, but the deal is it's got to work for every one of them. So let's see if it is. What's 1 plus 2.5? 3.5. What's 2 plus 2.5? 4.5. So guess what? There's our rule. X plus 2.5. There's the rule. Okay, example 4. In the cheese slicing diagram below, the input C is the number of cuts made across the center of the cheese, and the output P is the resulting number of pieces. Write a rule for the function. So the input is the number of cuts. So here's our X and here's our Y. Okay, so the first one has 1 cut, 2 pieces. 2 cuts, 4 pieces. 3 cuts, 6 pieces. 4 cuts, 8 pieces. So our rule is 2x equals y. There's our table. Well, I used x and y instead of p and c, but that's all right. Oh, then it said evaluate when 9, so then there would be 18. If you cut it 9 times, you'd have 18 pieces. Okay, so our guided practice, write a function rule for the input-output table, then use the rule to find, okay. So 0 plus -3, you know what? I got it right away. X plus -3 equals y. We'll check it. -1 plus -3 is -4. 0 plus -3 is -3. 1 plus -3 is -2. 2 plus -3 is -1. So we got it. So then we put in a 12 plus -3 is 9. So there's my rule, and there's my output when I put 12 in for my input. There we go. Good stuff. Oh, sorry, I wrote all over that one. Let me get that back here. All right. It's getting smaller, so I might have to subtract. Maybe divide. That's it. Divide by -2. So x divided by -2 equals y. 2 divided by -2 is -1. 4 divided by -2 is -2. Yep. And when I put in a 12, it would be -6. There we go. Example 5. In which statement describes the relationship between n and its position in the sequence? Okay, what do? We don't multiply it by -1. Multiply n by 2. So I'm just going to do this first one right here. Okay, that one's n. So 1 and -1. Multiply by -1. That works, but it doesn't work for the second one. There's 2 and 1. They got to work for all of them. Multiply n by -2. 1 times -2 is -2, plus 1 is -1. 2 times -2 is -4, plus 1 is, that doesn't work. Multiply n by 2, then add -3. Times 2, ooh, that works. Multiply by 3, no, it's B. All I did was go through and check it. Let's see if it works. It's eliminating them. What answer was it? B. Okay. Describe the relationship. So 1 plus 1 plus 2. So times 2, n times 2 minus 1. 2 times 1 is 2 minus, that doesn't work. 2 times 2 is 4 plus 1. 2 times 1 is 2. That doesn't work. What are we doing to this to get this one? Plus 1, 3, 5. Times 3 minus 1. There it is. 1 times 3 is 3, minus 1 is 2. 2 times 3 is 6, minus 1 is 5. 3 times 3 is 9, minus 1 is 8. 12. Ooh, so it's 3n minus minus 1. 3 times its position. I didn't write it out, but that was it. Ooh, those are tricky. So give them a shot. We'll see input, output, all those tables. Have fun.